we believe these optimizations have simplified our flow sheet, which bodes well for not only, as I mentioned, OpEx, but also the operability of the plant, reducing the risk around operability, which will ensure that we can get the throughput we publish, and also, very importantly, get the recovery, the overall recovery that we're targeting to get the rare earths out of the phosphogypsum.
Hello, you're watching Proactive. I'm joined by Rainbow Rare Earths CEO George Bennett, as well as Technical Director David Dodd. Gents, very good to speak with you. And George, looking very smart today. You're going somewhere?
Well, yes, I've been invited by the US Embassy in Pretoria to celebrate the 4th of July with them. So Rainbow have a very close relationship with the US government, hence my invitation by the embassy to Pretoria today.
Well, yeah. David, just going on to today's news, you've simplified the flow sheet quite dramatically. What's the biggest technical breakthrough that gave you the confidence to do that?
It's getting an understanding of how to control the impurities that come through with the leach from phosphogypsum, and in particular the fluorine which is present in the phosphogypsum stacks. We had a whole weak acid leach circuit and a recovery of fluorine circuit that was up front there to do that before we went into the main rare earth leach. And we established that we can in fact control the fluorine simply by adding silica and complexing fluorine with silica so that it doesn't affect the rare earth in the leach. So we've been able to eliminate a huge part of the process there. And then on top of that, we've introduced continuous ion exchange for the primary recovery of the rare earths from the leach solution. That replaces what was, again, quite a more complicated process involving fluorine precipitation and then subsequent strong agitated acid baking and water leaching with a simple CIX circuit. So those two in particular have greatly simplified our flow sheet.
George, from an investor's perspective, what does a simpler flow sheet actually mean? Lower costs, lower risk, or a faster route to production?
The first two are key, which controls our capital for the project that we've indicated to the market. We believe that will be well contained because these optimizations have reduced capital and OpEx. But, as you go into detail and finalizing the detail, you gain in the areas you gain, you lose in other areas in terms of costs. But these savings will have made sure that our capital is well constrained, as I said, within the number indicated to the market as at the October 24 update. The December 2024 update. And very importantly, it's made the plant far more operable from a HSE point of view, as well as a complex point of view. It's well known in the rare earth industry that rare earth plants are quite complicated. Hence, there are very few of them operating in the Western world. And we believe these optimizations have simplified our flow sheet, which bodes well for not only, as I mentioned, OpEx, but also the operability of the plant, reducing the risk around operability, which will ensure that we can get the throughput we publish, and also, very importantly, get the recovery, the overall recovery that we're targeting to get the rare earths out of the phosphogypsum.
Dave, the project's recovering rare earths from a waste product rather than mining fresh ore. What have been the biggest technical challenges in making that work at commercial scale?
One of the keys to what we've managed to do is to develop a process which uses completely standard industry elements to it, which we've combined perhaps in a way that's different. But every step that we take in the process is well proven, well understood. So the scalability of what we're doing is pretty much straightforward. But the key things that we really had to understand going along was the behavior of acid in the leach. It's not quite as straightforward as it sounds, and would take a long explanation of why, but that's a critical understanding which we've developed, which wasn't in place in work that's been done by others previously. Managing the impurities in that leach solution is another critical area, and particularly calcium behavior, because we're leaching a gypsum, which is a calcium sulfate. So at all times, we're in a calcium saturated situation, and calcium doesn't always behave particularly well. Most other rare earth operations do not have a calcium component to it. So this has been an area of, that we've had to make sure we've got a good grip on the behavior of calcium in our process. So I believe that we're in a very strong position with that now.
And George, with 3/4 of the process now locked in, what's left to prove before investors can look forward to the completed DFS?
Well, we don't have anything left to prove because we're going with standard separation, which is solvent extraction downstream now from our eluate. But basically, what's the key thing that's left is the CIX eluate that comes out of our CIX circuit that goes into feed the solvent extraction circuit. Just that interface, that's the final bit that we are working on, just to make sure, as Dave says, that the impurity levels are at the right level, which we have achieved. And now it's just that final optimization of that interface between the CIX eluate to feed the solvent extraction circuits. And as I said, the solvent extraction circuits will produce separated NdPr at 99.5% plus purity, as well as the ECG plus product, which is the key heavy product that everyone is looking for in terms of offtake. And in that ECG plus product, we've got circa 60 tons of dysprosium per annum, 20 tons of terbium per annum, and circa 130 tons of yttrium per annum. And all three of these are very, very sought after heavy rare earths right now.
George, Dave, I hope you'll continue to keep us updated with your progress. George, enjoy that 4th of July party, a very important relationship with the US.
Thank you. I appreciate that.